All right, I think we are live, everybody. I think we're live. This is the first time I have tried this, so we're gonna experiment with it this particular week, and we'll see the feedback. See if you guys like it. So this is the first time we're doing a Q&A live session on YouTube. I'm changing the platform mainly because the easy access that YouTube provides. If you do it on solely Facebook, that's great for those people who have Facebook accounts, and for different reasons I respect. I have lots of, well, not lots of, but I have some parents who maybe don't have an account or don't feel comfortable with their young learner being on Facebook, with the social media being kind of a dangerous place depending on how you navigate that. I totally understand that concern. And so what we're doing is we're doing live on YouTube. It lets you do that as well. And the good thing about YouTube is you don't have to have a YouTube account or have some sort of account in order to view the videos. So I can simply get the link to this. I can text it to you. I can send it to you via email. But anywhere you are, you should be able to watch the content on a cell phone or on on a computer, tablet, some sort of device. And we're going to try it this way. And you guys just kind of tell me what you think about it. All right. Same platform or same context, same kind of structure. But this is how we're going to explore doing it. And I think it's probably a good fit in all estimation. We'll see though, right? We'll see. So what we're going to do is we're going to start off. We have several topics. I'm just going to name a few because we have so many different clients at so many different levels. We have some people who are kind of like upper elementary age, and we're working on fractions. But to be honest with you, fractions is something I see that needs to be addressed for kids about K through 12. I mean, I got people in high school still struggled with fractions. They never felt like they understood it. Maybe they were rushed. And so I think this is going to be helpful for all of our viewers when I cover that. We also have factoring, of course. We have how to find x-intercepts or roots or zeros. We have the topic of polynomials for some of my clients who are wondering how to classify them. And of course, we have people working on linear equations, specifically how to write linear equations. So we're going to be flying by the seat of our pants a little bit. We're going to be covering a lot of topics. Let's get into this. So here's the first thing. I want to talk to my Math Made Simple folks who are doing maybe like, I don't know, if I had to put an age range here, you're looking about fourth, fifth, sixth grade, somewhere in between that range. And we're looking at just what fractions are. Remember, a fraction is a part out of a whole. It's a way of identifying that, and we use it in everyday life, and it has so many applications. Specifically this week, we're working on the skill of how to go from what's called a mixed number to an improper fraction, right? Specifically that order. Now, you can go both directions, but I like to break it up week by week because depending on how your skills are with division and multiplication, there is, you might want to space that lesson out for those parents who are working through this. So what we're going to do is we're going to take a very simple example. I got a mixed number. Now, a mixed number consists of a whole number portion and a fraction. So if you guys can see this, I'm going to put it up on my board. You got a whole number part and you have a fraction. So what we're trying to do is rewrite it in another form where it would simply just be a numerator over a denominator. Now, when I say improper fraction, see, this is a mixed number, but a improper fraction, typically, the reason we call it improper, not really typically, but always, is when the numerator is actually larger than the denominator. So, for example, if I had 10 over 3 or something like that, that is technically a fraction, but what they call that improper because the numerator is larger. And we had a good question come out in our session this week about, well, is that okay? I mean, can we do that? I mean, how is that possible, right? And so we're going to look at that in just a minute. But take a look at this. You have a whole number, a 2, and then you have a part. What basically this means is you got two entire somethings plus a little bit more of that something, but not all of it. That's basically what a mixed number is. So to give you a quick illustration, hopefully this will be helpful to you guys. If I see the mixed number 2 and 3/4, what I'm really going to do is I think the best visual is to give you 3 circles. I'm a big fan of circles because they're easy to cut up and make sense. And cookies, pie. I guess I like food, and so it's very easy to kind of see. Now, when I see the denominator of 4 in the fraction component, that tells me how many pieces each one of these figures is cut up into. So 3/4 means that each one of these is cut up into 4 pieces. So I am going to do that right now. I'm cutting these up into 4 pieces each. You see that? So I have 2 right here, plus I have a third right here. But here's how I interpret this. If I was to give you a visual for this mixed number 2 and 3/4, it literally means I'm going to color in completely 2 whole entire ones of these circles. We'll call them pizzas, for example. 2 of these pizzas. So I'm going to color this in. Imagine that that's shaded in. I'm not an artist, so you'll get the point. But we're going to shade in 2 of these. See how all 4 pieces were shaded in to shade in the entire. So this is one hole. Here's another hole plus 3/4. Now 3/4 isn't an entire extra pizza. It's just 3/4. So that means there are 4 total pieces, but I'm just going to color in 3 out of the 4. And this is kind of the visual for what this mixed number is. And I did this for a reason so you can see something, right? You have 1, 2 holes, right? That's why you have a big 2 right there. 2 hole. I colored in all 4 slices. So I 1 hole plus another 2 hole, but there's an extra 3/4. So it wasn't an entire extra pizza. It was just 3 out of the 4. And so this is a visual to let you see what I'm doing. Now, what we're going to talk about is how to convert it to what's called an improper fraction. So if you were to use the skill we talked about, you simply take the denominator of the fraction and multiply it by the whole number to do this. So for example, you would do 2 times 4, which 2 times 4 is really 8. Does everyone see that? 2 times 4 is what I would do first. And then I add that amount, that product, by the numerator. So we start by doing the denominator times the whole number. 2 times 4, that gave us 8. But then we have to add whatever in the top spot, that numerator. So we're going to do 8 plus 3. So that tells me 11. Therefore, as an improper fraction, I know that it's going to be 11 as the numerator. But remember, we keep the same denominator that you had in the fraction originally. That part doesn't change. So if this is a 4 here, it's going to be a 4 when you do the improper fraction. But this is practically the skill that you need to get comfortable with. It has so many uses as you move along in the grade levels, okay? So just to recap what we did, we multiplied the whole number times the denominator. That happened to be 4 times 2, and that's how we got 8. But then you have to add the numerator to that total. That gave us 11. 11 becomes the numerator, and then 4 stays the same as the original denominator, okay? Can you see that? Take a nice good look. So that's how we convert from an mixed number to what's called an improper fraction. Now, just practically speaking, let me explain to you how the visual helps us see this too. Okay. Remember, when your denominator is 4, or when your denominator is any number, that tells you how many pieces your figure is cut up into. So that's why everything was cut up into 4 slices. Each one of these 3 circles I cut up into 4 slices. But the numerator tells us how many of those pieces are shaded in or eaten or whatever the context tells us. So if you actually count how many pieces we shaded in, think about it. It's actually going to match up. Take a look here. If you all of this is 1, 2, 3, 4 pieces were shaded. Let's keep counting. 5, 6, 7. That's 8 pieces are shaded. Now let's keep counting. 9. Let's start here. 9, 10. Oh, look, 11 total pieces are shaded. If you count 4, that's 8 plus 3 more. That happens to be 11. So when I see 11 over 4, what I'm really saying is I have 11 of the 1/4 slice pieces. They're pieces that are cut up into 4. And so this is technically the same thing as this. They're the same thing. They're the same amount of whatever it is that we're referring to. It can be anything, right? But that's kind of what we've been discussing. Okay. So that's a recap of what we were learning this week with our Math Made Simple. But I do want to share one thing with you that is on your work this week that wasn't mentioned in the session. I think you can figure this out if you kind of read the instructions, but this is going to be a quick little extra teaching content. So there's something called a number line that you're going to, that people use a lot at different points throughout grade school math. And so what I want to do is I'm going to show you an example of a number line and how we interpret it, right? So let's see, 1, 2, 3. We're going to cut about each one of these into maybe 4 pieces. And so we're going to call this 1, we're going to call this 2, and we're going to call that 0. And then let's see, I'm going to draw a line, and I'm going to show you something here, hopefully. Whoop. I'm going to show you a figure that reaches about as long as this goes. Okay, excellent. Now we're just going to hash it up so you can see it real clearly. Let's hash that thing up. Okay. Now take a look at this. You're going to see an illustration for your work. It's page 1. One of my clients is doing this right now. And what they have is a number line. This horizontal kind of straight line that goes left and right at the top is called a number line. And what we've done is we've cut up this number line into pieces, just like you cut up circles into pieces or squares. Notice it's cut up 1, 2. It basically has 4 parts, right? 1, 2, 3, 4. 4 parts to get to the next number, right? To go from 0 to 1, you see these little hashes here. So this is cut up into 4 pieces, right? If you go another 4 pieces up, you're going to hit 2. And so what they have is a picture of a figure. This is a rectangular figure below, and we want to know how far it extends. Well, if you think about the fact that each one of these little segments between 0 and 1, 1 and 2, between the numbers is cut up into 4 pieces, groups of 4, then you're able to figure out what the mixed number is. So to go from here to here, that's all the way up to 1 on the number line. If it keeps extending, notice it hits past 2 on the number line. So we would say that this figure is 2 for the whole, but notice it goes a little bit past 2. It goes another little piece, maybe one more hash over. So we notice it goes one more piece over, but remember each one is cut up into 4. And so this would be an example as a mixed number as 2 and 1/4, because the extent of this rectangular figure goes 1 whole, 2 whole, plus another 1/4. Now, if you were to cut it up and think of it as a not mixed number, but think of it as an improper fraction, you would literally just cut up how many pieces you see total. So if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, looks like there's 9 of them. There's 9 total pieces, but remember each one of these is cut up into 1/4. So we would say 9/4, right? And if you do that trick we did earlier, if you multiply the denominator by the whole number, that's 2 times 4 again, plus 1, you'd end up getting 9, right? And that matches the skill set that we looked at. So anyway, you can replay this video and rewind it as much as you need to. If I went a little bit too quickly, as soon as it records, after you do the live, it does the recording, but that's just something I wanted to share. Okay, sounds good. All right. So let's move on to the next topic. So we have several topics we could discuss. One of the topics I wanted to talk about had to do with writing linear functions, okay? Writing linear functions. So that's something I probably, almost every live I've done some sort of linear function, because it's such a huge component in Algebra 1 and frankly, Algebra 2. And so we're looking at how to write a linear equation when you're given the slope and the y-intercept, or maybe given a table. And so what I want to do is just remind you of some things. One of the first things you need to make sure you know is something called the slope-intercept formula, okay? I gave you that in the class, but we're going to look at it again. That's y equals mx plus b. This is your friend, okay? Y equals mx plus b. If you are trying to write an equation that is linear, you need to have two things. You got to know what the m is, and you got to know what the b is in order to write an equation. So when you're doing your work this week, you're going to see quite a few questions that flat out tell you what the slope and the y-intercept is, okay? They don't say m and b. They'll say the word slope and y-intercept. So if you see a problem and they say, hey, Chris, the slope is equal to, I don't know, 4, and the y-intercept, I'm going to say y-int, the y-intercept is equal to 6. Okay, let's say that that's a problem. And they say, here's number 1. Can you write the linear equation? The slope is 4, the y-intercept is 6. Well, what they're really saying is the m is equal to 4, right? Because the slope is 4. And the b is equal to 6 because y-intercept means b. So all you got to do is use this slope-intercept form equation and substitute m and b. You're done. You're done. So if you look right here, I'm just going to write it as y equals the slope was 4x, and then the b was 6. I'm going to replace the b with the 6, and I'm finished. Let's just do a little circle around that thing. There is the linear equation. Keep it simple. You only need 2 things to write a linear equation. You need to know the slope, and you need to know the y-intercept. So these should be the easiest questions you see, whether you're taking algebra in a typical school setting, you're homeschooled, or trying to figure it out on your own. You just need those 2 things and this little template here called the slope-intercept form to write a linear equation. You can put it in your graphing calculator. You'll see exactly where that line shows up on the coordinate plane. But unfortunately, or fortunately, you aren't often given the slope and the y-intercept straight up. Now, some of these will give you on a test, maybe 4 questions out of a 25-question test or something. But a lot of the times, they're not going to make it quite that simple, right? So, for example, this week we're working specifically on how to identify the slope when you're given a table. That's a very common one. So I want to sketch a little table for you, show you what I mean by that, and then just make sure you feel confident there, right? And like I said, if you ever are doing this and maybe you've had some time with me and you're just still confused or you don't remember, I don't mind shooting me an email, text, just to kind of get reminders, and we can clarify a lot of that stuff, right? I'll probably just do an extra page here because I'm running out of room. Oh no. Okay, so forgive me. I got to do it this way because I don't have the software to share screen on YouTube. But here you go. This will work just fine. Okay, let's say you have a table that has a bunch of X values and a bunch of Y values, right? And they tell you to write the equation of the line, right? Write the equation of the line. So this is an example of one of the ones that you will be working with this particular week. The first thing you need to figure out, I'm just telling you the truth, you really need to figure out that M, okay? That needs to be the first question you're wondering. So in other words, the slope. Now you can do this a couple ways. I gave you the slope formula, but another way you can do it if you're given a table, and you frankly did a really good job of this during our session, is basically just look at the rate of change, okay? Look at to go from 0 to 1, 1 to 2, 2 to 3. Look at the X column and ask yourself, what's it increasing by or decreasing by? This one's going up to 1 to 2 to 3. It's increasing by 1. Okay, so that's a rate of 1 as far as the change in the X values, right? Well, if you look at the Y values, it just so happens that it's the same thing. It's increasing 6, 7, 8, 9. It's going perfectly in order. It's increasing by 1. So we would say the rise is 1, the run is 1, but that frankly reduces to 1. 1 over 1 means 1 divided by 1. So I just found out that the slope, the M, is equal to 1. So that's half of the information I need to write the linear equation, okay? It's really that change in the Y over the change in the X's, right? What's the difference happening in the Y column? Put that at the top. What's the difference happening in the X column? Put that at the denominator at the bottom, and you got your slope, okay? That's an easy way to do it when you're looking at a table. Now, one of the things we talked about is, well, how do you find the next part you need, Chris? I need to figure out what the y-intercept is, what the b is, right? Well, hear me loud and hear me clearly. When you're looking specifically at a table, okay, they don't always show it, but a lot of times they do. The y-intercept will always be wherever the x is 0. So, for example, right here, you notice the x column has a 0. Well, the y that's directly next to the x at 0 is your y-intercept. So when I'm looking at this table, 0, 0, comma 6 is really what that is. That tells me that the y-intercept is no longer a mystery. I know it is equal to 6. The y-intercept will be wherever the x is 0. The y that's next to that 0, that's going to be the y-intercept, okay? And the reason is simple. The y-intercept is where it crosses the y-axis. So if you find that point and actually plotted a point at 6 and right on top of the y-axis, the x would be at 0, right? It won't be left, it won't be right, it'll be right in the middle. And so 0, comma 6 would be the ordered pair, and there's your y-intercept. So now that I know that the M is and the B is, I simply use my slope-intercept form. Y equals 1x. The B is 6 plus 6. And there it is. Now, do I need to put the 1 there? Probably not, but this is not incorrect. This is perfectly fine. If you're taking a multiple choice test, I'm just warning you, they'll probably just leave it as x plus 6, okay? Because the 1 is understood to be there. So whether you put a 1 there yourself, but if you're taking a multiple choice test, I'm just warning you, they'll probably just have the answer written like this. There's your equation. Y equals mx plus b, okay? And so that's the main thing that you're working on, is how to write a linear equation when given the slope and the y-intercept straight up, but then also being able to figure that out when you're given a representation such as the table. Okay. All right. So those are two topics we covered. We looked at some fraction work. We looked at some linear equations. Now I want to talk to one of my clients who's dealing with the concept of polynomials. And so we were talking about how to classify polynomials. That's very important because you go through Algebra 1, you look at different types of functions, quadratics, you look at cubics, you look at the graphs and how they, it's all built off polynomials, right? And so we want to talk about how we can classify them, which is really a fancy way, honestly, of saying naming them, right? We talked about how me as a person, my name is Chris Morris, right? Well, that's how you know that I am who I am. If there was about 50 guys in a crowd, if you just yell, Chris, Chris, there's a good chance that 10 of us are going to turn our head around and be like, what? Because it's such a common name. But if you say my last name too, Chris Morris, well, that narrows the field. Hopefully there's only 2 of us then. I've seen that actually many times. I have such a common name. But if you really want me, you're going to say all 3 of my names. I'm not going to say that now. But That would be my first, middle, right, and my last name. Then I really can narrow down the kind of person or the actual person I'm looking for. Well, the same thing is true of polynomials. For example, you can have all kinds of polynomials. Here's one example. Believe it or not, just a normal number, a constant like 18, is a polynomial. It has one term, so we call it a monomial. Mono meaning one. So we have one name based off of the number of terms you see. Monomial. I think I spelled that right. And then there's another name for the degree. Now, if you don't have a variable on a polynomial, it's just a number. We call that a constant because the degree would be 0. Those are called constants. So the classification here would be a constant. Sorry, I've made it so close to each other. A constant monomial, right? A constant monomial. So you got two names, constant, and then the other one's monomial. All right. And so that's just one example. You could have several. Let's look at this one. This is a very common one you'll see a lot of. Right here, you have 3 terms to this polynomial. And remember, a polynomial is a series of terms that are joined together by addition or subtraction. It's that simple. Series of terms joined together by addition or subtraction. That's what a polynomial is. Okay. That's a generic term for any of those kinds of situations. But right here, if we want to get real specific, we can name it based on 2 factors. We can name it based on how many terms you see and also the degree of that polynomial. So if you look right here, I'm going to start with degree this time. You'll notice that the highest degree out of all these terms would be this one right here that has an exponent of 2. That means the degree is 2. That means the whole polynomial is going to be a degree of 2. All right. You look for the highest power basically in the set. And so since the degree is 2, there's a special name for a degree of 2. We call that a quadratic. Okay. And it can be confusing because a lot of people think quad means 4. And to be honest with you, it usually does. I don't really understand why in this particular topic, quadratic means 2, but you just have to know it. Okay. But that's the special name we have for a degree of 2. It's quadratic. But then you also can count how many terms it has. 1, 2. Oh, it has 3 terms, right? So there's a word prefix for 3 that might be coming to mind right now. That's called tri. And so we call this a trinomial, because it has 3 terms. And so together, we call this a quadratic trinomial, a very common, popular type of polynomial you work with a lot in Algebra 1, quadratic trinomial. And so this is how we classify them, okay? This is how we classify them. Now, as a reminder, if you've been in my class, you're also going to be adding and subtracting polynomials. Remember to look for the same variable and power. They have to have, x squareds go with x squareds, or y cubes go with y cubes. You can only combine like terms that have the same variable and the same exponent, the same power. Otherwise, they're not alike. You can't put them together. I think you knew that. You did pretty good in class, so I just wanted to share that with you. All righty. Let's see. We've reviewed so the classifying, and in fact, it even gives you several examples, and it gives you the names. So you just have to spend some time, refer to it, do enough of them, and then they start coming to you over time the more you do repetition, okay? So the next thing we want to look at is I got one client, or maybe a couple, but I got one client in particular I'm thinking of who we're working on factoring, right? And so there's a new type of factoring process we introduced in the class, and that process was called difference of squares. And so as a reminder, I'm going to put up one like this. A difference of squares means you have 2 terms that are perfect squares that are being subtracted by each other. Okay, 2 terms that are perfect squares that are being subtracted by each other. And not only did we look at that particular type, we looked at how to also take it a step further by doing what's called solving by factoring. Okay, and that's whenever you see your polynomial set equal to 0, that's a key right there. They want you to solve it, not just factor it. So here's your quick recap. When you have difference of squares, that means there's something times itself. The same thing times the same thing would equal the term. That's what a perfect squared is. So for example, 81x squared is a perfect square. And the reason is 9x would be the square root of it, right? If I were to do 9x and multiply it by itself, 9x, I would get 81x to the second power, right? That's how I know that this is a perfect square. All right. So what we do is something called square rooting. Square rooting means what is that number? What is that term times itself that would equal this? That's what it means to square root. And so we just determined that would be 9x. Okay. So what I'm going to do is I'm going to put 9x in the first part of 2 parentheses here. Okay. Now I got to do the same thing to the other term. That's 49. Well, there's a number times itself that equals 49. The square root of 49 would be 7. 7 times 7 equals 49. So that's going to go in the other space. The only thing you got to remember with difference of squares is you add it once and you subtract it once. That's all you got to do. We factored it. Okay. It's a special case. And we reviewed that yesterday. So just so I have room, I just want you to remember that this all equals 0 and I'm running out of room. But don't forget to bring down the equals 0 because you still have to solve it if it has an equals 0 from the get-go, right? So how do you solve it once you've factored it? I mean, that's a new step. Well, all you got to do is take each factor and set that factor equal to 0 and solve it like it's an equation, right? That says 9x plus 7 equals 0. So how would we solve for x? Well, you would just do the same stuff you would with two-step equations. You'd have to start by minusing 7 on both sides, right? That would give you 9x equals what? -7. And I'm running out of room, forgive me. But that last step, it's 9x, right? You got to do the inverse of multiplication. 9x means times. So you'd have to divide both sides by 9. And so if you do that, you're just going to end up with x equals, running out of room here, but x equals -7 over 9. You could literally leave it like that, -7 over 9. Okay. And you do the same thing to the other factor. Remember, you will have two solutions. If you have a degree of 2, you're going to have two solutions. By the way, if there's a degree of 3, you'd have 3 solutions, but that's another lesson for another day. But to be honest with you, I think you get that. That little quick reminder is going to be probably all you need. Now, if I'm wrong, like I said, email me, ask me your specific questions. Don't mind getting back to you when I can. But that's just pretty much what I'm going to say on that. Don't forget that the points where those two solutions you get is where the parabola, the shape that generates on the graph touches the x-axis. And there are 4 names for those. You can call them solutions, roots, x-intercepts, or zeros. Solutions, roots, x-intercepts, or zeros. And those are the things that you need to keep in mind. All right. So we're making really good progress. We also have people in our Money Made Simple program. And so I just want to leave some thoughts with that. One of the things we talked about was just the various ways you can save money, giving you, just introducing the topic. We looked at how to do the budget breakdown last week. And so we gave some very wise, it doesn't have to be rigid, but some loose percentages that you could consider putting towards different categories of your spending. Maybe 10% of your money going to giving, 15% of your money automatically going to some sort of savings, whether that's a mutual fund, a savings account, CDs, whatever. Okay. We talked about how 25% of your income should be going to housing, not even a percentage higher, right? If you're spending more in housing than 25% of your income, you probably can't afford the house. And so things like that. We did some exercises based on different income amounts so you could see how much money you could actually afford to put in that bucket, right? Well, then after we moved past that last week, we started looking at just the beginning topic, just some creative ways that you can save money now. People think, oh, I can't afford this, or this is too much, or I can't get out of debt because life costs too much. You'd be amazed ways that you can save money, such as, canceling automatic subscriptions that have your bank and debit card information where maybe you're paying $10 a month and you don't even realize it and you haven't used that service. Maybe you don't use Hulu. Nobody in your family watches Hulu, and you could drop that and save some money, right? Maybe, one of the things we talked about is cable. You can cut cable. At this day and age, with the internet being what it is, there's lots of ways to watch what it is that you really care to watch, but you don't have to pay those crazy cable bills. They're not cheap. And with streaming, it doesn't have to be as expensive as it is. One of the other things that's huge for people is really the wisdom of insurance. We talked about insurance is a biggie. It's very expensive, but if you can watch your policies every year, shop around, use something called an insurance broker, not necessarily a person who works for one company who only sells you products from that one Allstate company or that one Starbucks, excuse me. I'm thinking of State Farm is what I meant to say, not Starbucks, but that's another way to save money. But a broker isn't bound to just one company. So they can look at all the companies, all the policies, look at so many different things, get you the most amount of insurance for the least amount of money. That's something that I think is wise, and it can save you hundreds, if not thousands of dollars, especially if you actually had to use your insurance policy. You want to make sure they're going to do what they say they're going to do, and they look out for you. Think of it kind of like a real estate agent who's looking out for your interest. you kind of want that as well in that category. So moving on from there, the other thing we discussed is, the value of percent. We looked a little bit about percents when we did the budgeting exercise, right? Really quick ways to calculate. But the other thing that we looked at yesterday was specifically, ways to calculate different things, right? Because if you want to get deals, if you want to take advantage of sales, if you want to know exactly how much is this really going to be so you're not blindsided when it's time to check out, you need to do the math ahead of time. Look at your income and see if you really can afford to make that purchase or not. After doing the math ahead of time, you might be able to conclude, I don't really need this. I might want this. This might be nice to have, but it's not a need to have, right? And so we looked at a very valuable formula for calculating that in different ways. One of the formulas that I like to use is this one. It's part over whole equals your percent over 100. This is a very, very useful, practical thing that you can do with your young teen parents to make sure that they're able to always figure out the percent. They can get discounts, they can calculate how much money they're going to save, and then we can talk about sales tax, add that back on to the price so they can get a realistic picture as to what they have and what it is that they can afford to purchase, right? So if you're looking at a situation, this is just a made up situation, right? So just theoretical. But let's say, you want to buy a new smartphone. That's a very common thing that everyone is spending their money on. And they're getting more and more ridiculously priced, right? I think a new smartphone these days, you're looking at anywhere from like $1,200 to $1,300 for a phone. I mean, that was not an expense people your generation, when you were a teenager, ever even conceived of. You're dropping that much money, you thought you're buying a car, right? Well, they're just buying a phone. Let's say you got a new smartphone that's on sale for 20% off, right? We're not even talking about tax. We're just talking about it's 20% off. You'd be amazed, parents, and you might want to ask yourself, does my teenager even know how to find out how much money that would save them? Do they even know how to do that? Well, this is a cool tool you can use in order to help them and walk them through that, right? We talk about what's the part, what's the whole. Well, the whole price of that phone, according to what I just laid out, would be $1,200. The whole is the entire price, right? You want to make sure you say that to them. And then the part, that's what we're trying to find out. Like, what is 20% of $1,200, right? Well, remember, percent means out of 100. So when they bring up a percentage and you see that symbol, you need to know that that goes over 100 every time, right? Because that's the definition of percent. So this little illustration, this simple tool, can be very powerful for helping kids be able to calculate their own discounts and actually know how much it really is going to be. And you'd be amazed they can make a better informed decision and be intentional about where they spend their money, right? So how do you solve an equation once you have it set up like this? Well, we talked about a process called cross multiplication and division. So if you cross multiply x times 100, you just write that as 100x. That's just kind of an algebraic concept, right? Anytime you got a variable times a number, it just looks like that side by side. And then you're going to cross diagonally multiply the other way, right? You got 1,200 times 20. So I believe that's 24,000, I think, but I'm doing that in my head real quickly. So if you want to work it out with your kid, I'm going to do it again just to make sure I didn't do anything silly. Just get out a simple calculator that comes on your phone, pull up the calculator app, and just double check that. But I believe that's correct. We're going to do 1,200 times 20. I was right, 24,000. You just want to be careful there. And then that last step, you actually solve it like a one-step equation. So 100 times what number equals 24,000? The easiest way to do that is divide both sides by 100. That's just a little algebra, right? But it's useful here. Take that 24,000 and divide it by, Divide it by 100, and that will be your final amount. So we now know X equals, no longer a mystery, X equals $240. Okay. So when they say, hey, today you come in, you can get a brand new smartphone for 20% off, your child needs to know that that means $240 less than it normally would be, right? So you're looking more about $960 before tax. Talk to them about the sales tax of your state. Talk to them about, you got to add that into the cost. A lot of times, if you're doing a payment plan, they're going to make you pay for the entire amount of the sales tax up front, and then they'll give you the payments. But anyway, we'll get into that kind of stuff later. But those exercises are really cool. It's empowering for the kid. It's empowering for the teen, because now it's not just, okay, I'm going to save money. We'll find out what they tell me at the register. And then you got somebody who does something janky at the register, and next thing you know, you lost money, and you don't even know that you lost money. And the people who know the math don't necessarily have integrity to tell you that every time. You need to know what that bill should be, so when they give it to you, you're not surprised. You've been intentional. You already knew how much money you could afford to drop, and so you go in there with a plan and execute that plan, if that makes some sense. So anyway, I'm going to leave it on that note, because I don't want to give away obviously the whole content of what we discussed on one of these lives. This is something that a lot of people can kind of glean some knowledge from. But this is just a quick little overview of some of those topics. Hopefully, it's a refresher of what we discussed. So when I touch on that, when I give you that little reminder a couple of days later after our session, all of a sudden it floods your mind. Oh yeah, I remember this, and I remember this, and I remember this. It's kind of how the human mind works, right? So anyway, I'm out of time on this one, and if you didn't catch it live, I'm going to go ahead and I'll try to find the link and send it to you guys via text or email. Check that out and watch it when you can. Let me know if you still got questions. I'll catch you all on the next one. Peace.